Okay, so welcome. I'm going to present today a bit about what are we doing at Thomas Cook and microservices and how do we run them on AWS and Lambda functions and a bit of other things, what I've heard, what I've seen during the talks today. Just a little bit of a background. Who am I and who do I represent or who do I work for? So I'm Pascal Laenen. I'm group head of Numo Labs, and Numo Labs is like an innovation cell within Thomas Cook. And what we do is we actually try to disrupt what is already there. And we try to use new technology to generate business value, because at the end, everything what we do, how good engineers we are, if we don't create value, we won't get the money to do the next cool thing. So I'm always looking at how can I create business value. So Thomas Cook, we are around 22,000 people, 1,000 IT, just to give you a little bit of an idea. And we exist since 1841, traveling. I don't think there was a computer at that time. Okay, the brief history. We started around 6 years ago, 7 years. We're an Oracle ATG web platform. We release new features every 4 to 6 months. And a release in general took around 4 days because there was always something going wrong. Then we moved to Spring Framework, built our own app, started using SOAP calls, unfortunately, but started to separate slowly the UI and the backend through the service-oriented architecture. But still, it took 1 to 2 months to release features. So we're only able to add business value every 1 to 2 months. And then we went to NodeJS UI. We used Angular, and it was our first attempt to be a bit more agile. We started to create horizontal teams, end-to-end responsible, and nowadays everything runs on NodeJS, Angular, and then it goes further into our backend systems. And yes, we still use some COBOL on some mainframes. Yeah. But what is next? What would you do if you were a startup and you were able to create a tour operator from scratch? That's a question, and that's the thing I want to talk about today. So how do we actually support business capabilities with those ever-changing requirements, because the business never knows what they want, with impossible timelines, limited budgets, but they still ask for perfect quality, security, resilience, and a low total cost of ownership? Yes, we are human, and unfortunately that's what IT is about. It's always trying to do, with the minimum amount of money, the maximum for the best quality. So how easy is it? It's actually fairly easy to develop new features. I think everybody can really build new stuff. But who of you dare to say, I can delete whatever line of code without being afraid? Yeah? Not a lot of you, I guess. So how afraid are you of deleting code? And what is actually the architecture you have to put in place so deleting code becomes easier? Because if you're able to delete something, it means you can get rid of features which are not bringing business value. So you don't have to maintain them anymore. And that's where real value sits, and that's how you should architect your applications. So design is actually not only about how it looks like and feels like, but design is also about how it works. And one of the things we have to do as engineers and developers and architects is explain to the C-level, how do things work? Why are things sometimes complex? Why are certain things which look very simple so complex to do? Why are things which look very complex sometimes just a matter of a few hours and we can execute them? It's all about how it works, yeah? And about communicating how things work. And then my favorite one, caution. Keep clear of moving parts. Everything what moves will break at a certain moment. So I'm a big fan of no-ops, but what is no-ops? We all need a bit of ops, but I'll talk a bit about how no-ops fits in what we're doing. I don't like virtual machines because actually it's the same as a normal machine. Okay, I can boot it up faster, but I still have to do upgrades of my kernel, etc. At the ops side, things remain the same. So I don't need the infrastructure guy bottleneck anymore. And I don't want to chef and puppet and whatever is there. So how can we simplify? Because the less there is, the easier it is. And do you bend or break? Resilience. How many people really think upfront about the resilience of an application? Most of you will say, yeah, we do. Yeah, but not everything is equally important. So if something breaks, is that really going to break your core function? And is that going to impact your bottom line sales? 2,000 of our hotels generate about 80% of our revenue. If that stream works, actually I'm happy, and that should be very resilient. The other bit, the 20%, which had a lot of complexity, does it have to be built in the same way as the other percentage? I don't think so. So it's all about scale for purpose, build for purpose, and don't over-design, don't over-engineer, but do what you do very well. And then, in my opinion, let developers use their fit-for-purpose programming language of choice. If I want to build in Node or Java or Python or Go, and unfortunately I did not mention .NET. I don't really see it as a programming language yet. We're on a G conference, yeah? But I'm a big fan of Node, and I'm really a fan of Node mainly when it goes about I/O. I just want to do things fast. Use I/O. When I want to have something what is more CPU intensive, I will use Java. But why not let both live together? Why do we always have that competition? It's about what value do I bring at the end? What am I building? How are my customers using what I've been building? Automate. Everything what you do manually is evil. It's really, really evil. Because you know, you will do it 2 times, 3 times, 4 times, and the 5th time you will probably do it a little bit different and it will break. So try to automate whatever you do. And when you automate it, and it's hard to automate, then probably you have made it too complex. So think about that when you're building something. So we started building some APIs, and we have affiliate connections on web and mobile apps, and had an API gateway for security rate limiting. And then we saw that actually the applications were replicated in the APIs we had. We built for every application an API as an aggregator and to provide the right format. So hey, cool REST, but it doesn't really work for me. So what we did is, how can we simplify again? I want my API gateway, an API facade, and a set of microservices underneath. Now let's go a little bit in detail about the definition of a microservice. And Martin Fowler, a great architect, he actually defined it this way. He said, they can be developed without a developer having to know actually the full application scope, because it's all about defining contracts. And let that one microservice do one thing and do that one thing very well. Yeah? Major versioning only on a microservice level. I don't care about minor versions or patches or whatever. As long as it's backwards compatible, it's good. So we only version, the major versions are important for us. All the rest should work, is backwards compatible. They're independable testable. You should be able to isolate them and test them end to end, including performance testing of that single component. Because at least you know then, when you do your overall performance testing, what is the effect of that single component in the bigger picture? And a clear contract. They definitely have to have a clear contract about what they consume, but also what they produce. And I highlight consume because it's very interesting to see if you have all those microservices consuming a lot of data, what I would like to know, who's consuming what. Because maybe I can simplify something in the next version because nobody is using that certain element, and we keep publishing and have to remain creating code for it and maintaining that code. And they don't share data outside their domain, and that's a very important one. From the moment you have like 50 microservices and they all go to the same database and use joins and everything there, then good luck with your monolith there. So yeah, I'm going to quickly go over this one. eBay, Twitter, Amazon, everybody is going into the microservice world. So this was our first attempt. And actually it is in production, and we use it for integration within Thomas Cook. RabbitMQ, we created our own microservice framework. We have an F5 load balancer, some Nginx service, and then we create the proxy service and all those little microservices underneath. But then actually we came to the conclusion that 80% of our use cases were synchronous. So why put everything over a message bus and make things complex if 80% is request response? And 20% of our use cases was only asynchronous. We are moving more and more to asynchronous, I have to say. However, AWS came in. We said like, okay, let's try to simplify and look at what would we do as a startup. So I have here my UI. Then I have my CloudFront, which is my CDN. I go to my AWS gateway, which is my REST endpoint. And from that endpoint, I go to a Lambda service. And the Lambda service, I can call other Lambda services, or I use SNS with pubsub, and then go to other Lambdas which are registered to that SNS and can write to Dynamo, etc., etc. Yeah? So let's take an example here. Autosuggest and some NLP we have written to detect actually different entities within a string. But I'm mainly going to go on the autosuggest. How would you build that in a serverless architecture? From a UI perspective, we moved to React and Redux. And it will be clear why. The main reason there is simplicity, the option to go to React Native in the future, which I can use for mobile development, but also because it works very nicely together with GraphQL. And let's go a little bit in what is GraphQL and what does GraphQL actually mean. So GraphQL is my single REST endpoint. I only have one REST endpoint anymore, /GraphQL. Simple, yeah? Not a lot of moving parts, easy to document. Hey developers, here is your endpoint, it's called /GraphQL. That's it, start developing. So it's behind our API facade, GraphQL, and then we go to our auto-suggestion provider. And what is GraphQL actually? GraphQL, Lambda here, let's first go to Lambda. Lambda is a function which runs on Amazon, and you don't have any virtual machine anymore. You just have a single zip file, you upload it, you put in some Node code or Java or Python code, and it runs, and it has an event handler, event and context, and now they've changed it. With Node, you can also do now a callback function, so you don't have to do the context fail or context succeed anymore. And you just pay per 100 milliseconds that it runs. So I don't have to care about scaling anymore because I can run concurrent 100 of those per second. 100 is nothing. Yeah, just do a simple call to Amazon. You log, I want to extend it to 1 million calls per second, and they say, okay, why, and what is the peak, and what do you expect? And they will just limit up your limit. So you can run 1 million concurrent requests per second if you wish to. So that's an important one. When you start using it and you hit the limit, look at that one first. Yeah. So what is then the pricing example there? If you do like the 3 million requests and they all run a second, then you will end up $18 a month. And I don't have to maintain a virtual machine. I don't have to spin them up. I don't have to worry about them. I don't have to monitor. And I don't have to think about memory leaks within that function, because actually it's each time it's spawned again, and it works like an SD in, SD out, and that's it. So it just lives for the 100 milliseconds you want to use it, and then it's gone. So that's here. Let's go to GraphQL. So GraphQL is a query language, and it was introduced by Facebook. And actually it gives you the opportunity to do kind of services, searches like, let me see if I have an example here. This is one which we've built. One of my colleagues has built a service of GraphQL which allows you to search for artists on, I think, one of the FM channels, an API. So you just ask for, I want suggestions for on the beach. I run it, and I get like a list of suggestions with everything what's in place. So this is actually the query language on the client side. So for each client, I can determine, oh, I don't need the images, I only need the name. And that's it. I will just get the name back. Okay? That's how you can create multiple clients, can use the same service, and I have code completion. I have insights. Ah, okay, I'm so interested in URL. Just execute again, and I get my results back. And that's what GraphQL does. It's in that way very powerful. One REST endpoint, you define your query on the client side, and the server will take care of it. So the server, the GraphQL server, will actually get the command, will distribute it to the different microservices, waits for the response, aggregates everything together, filters out what's not necessary, and sends it back to the client. So the same client can be used, the same GraphQL endpoint can be used by web and mobile at the same time, with maybe different requirements, different fields, which you want to ask for. So let's go back in here. So you can have code completion, everything, but you also have documentation available. So it's auto-documented, no Swagger anymore. The Swagger hell, like I call it. I really don't like it. Because you just define this is your public API, you expose everything, you define your schemas, and this is actually how it looks like. The only thing what you do is GraphQL, require GraphQL. This is my autocomplete service, which goes to my microservice. My autocomplete list type, which is an argument of the type GraphQL, and it resolves and gives results back. Yeah? Then the API gateway is actually used as an endpoint where we configure and say like /GraphQL, a post command, link that one to a Lambda service. So every time when I call this endpoint, I will actually execute a Lambda function, and the Lambda function here is AWS Lambda, GraphQL version 1, and a stage variable. And with that stage variable, I'm able to run the Lambda services for CI and production at the same time, in the same environment. Because actually I can just say here that for CI, I add the value CI, and for prod, I add the value production, and I label my Lambda functions, and in that way I can run multiple versions at the same time. That's a quite clever way of doing that. Multivariance testing then. If I build an e-commerce platform, then A/B testing is something what everybody does. But most of the A/B testing is done on the front end. But actually, what I'm mainly interested in is how can I test at the back end that auto-suggest service? Because maybe I have two versions at the same time, and I want to see which one works best. So what I can do is I can inject a unique test ID on the UI and actually let it propagate through my stack till I'm on my GraphQL API, which will then look, do I have a specific version available for the auto-suggest? And then I run, for 10% of the cases, I run the auto-suggest version 1, and another, I just run the test one. Yeah? And that's how you can test on microservice level. We had some problems with building this, and mainly because every Lambda function, we needed a bit of helpers around it. We created a Lambda helper NodeJS module, so feel free to use that one. It helps to isolate the Lambda code itself, and it helps for testing purposes too. So feel free to use that one. But then continuous delivery. How do you ship your Lambdas? We use CodeShip. Why? It's easy. I don't have to install a Jenkins, or I don't have all those complex Jenkins scripts. I have 3 lines of code in my CodeShip. And I am able to test and deploy functions in 33 seconds. Try to do that with your Java apps. Because we're talking about microservices, which are around 200 lines of code, I can rewrite them in a day in another language. So that's what we're doing here. Now we build our own UI, which actually says like, okay, is there a difference in the version between CI and production, yes or no? If there is a difference, then I can just click promote and it will be promoted to our production environment. And it's as simple as that. And that's what I call no-ops. Because developers are now responsible for moving from CI to production. And they have the capability. But power comes also with responsibility. It would be nice to only get power and no responsibility. But it means that the developers are also responsible to keep things running in production, to look at metrics. But look at business metrics. How many bookings did we make? How many searches? How many searches did result from a search into the booking flow? Because that are the real metrics which count. I don't care about CPU levels, about memory and everything. As long as nothing hits that count, that's the bottom line, because that's where we make money. So a bit of pros and cons there around microservices. So each microservice is simple and should be seen as a product. Yeah? We can scale them independently, and it also means you can do caching strategies and different caching strategies on a microservice level. We can optimal perform tuning them. It's easy to test them on its own. They're easy disposable. Remember the question in the beginning, how many people are able to delete some code? I can delete microservices fairly easily. Of course, it has an impact on the applications which used it, but it's very easy to isolate that code and to test the rest of the system without that service in place. Restricted access to code. If I have distributed teams, maybe not everybody has to have access to everything of the application you're building. So I can build components with different developers who can only see that bit. As long as the contracts are in place, everything will work. We group them in business domains. We decentralize data management. So you use the best data stores for what your microservice does. But as you can see, is also a con, because distributed data can also be very complex, definitely in transactional systems. So just be careful for where you use microservices. It's not a Swiss knife. They lend themselves to infrastructure automation, design for failure, and an evolutionary design, because you can start something simple, you can use Node, then developers want to use a bit more of Java, or everything, it's language agnostic. And AWS is planning to also give Go as a language available for Lambdas. So just use what's best for you. If I want to do image manipulation, I might use Go. For my I/O, I use Node, etc. Yeah? The con, however, is all those little microservices to see what's going on in your system is sometimes hard. So think from the beginning already about monitoring and how your application is going to work, and tracking IDs which go through the full stack. So at least when you push everything through CloudWatch and then trigger it and load it into an Elasticsearch, for example, you can see based on a tracing ID what was executed and how long did every step take. So dependency management, and it's very, very important that you also create a repository and at least a catalog which says those are the microservices which we have, and that's what each microservice does, because else you will start just generating again a monolith with all those little services and nobody knows what is what and what is it doing. So we do that together here with Cyclem. We're setting up 2 teams now, and they're working on the new bits. We have in total 87 people already working in that model. Teams in Kiev, teams over here. And it starts working really well because people are really interested in work with new technology while still working and being part of the Thomas Cook group. So they have really the feeling that they're part of Thomas Cook. And I think that's important to work like that, because me as an architect and as a lead, I just want people who are motivated and are part of the culture, but also generate business value and help us to generate that business value. And it's very important that developers get that business sense too. So from a pro tips perspective, if you start doing microservices, don't just rewrite everything because you will fail. I did it out of experience, so try to extract small things and decouple and create small services for the less important bits. Build up experience, let it run in parallel, and slowly start moving more and more to your microservice architecture. Understand also the hidden schemas. Document your interfaces and document them very well. Keep your services backwards compatible. And that's culture. That's all about discipline. And that's independent in what language you write, but keep things backwards compatible. Build in your operational metrics from the beginning. Yeah? But Amazon does do actually already quite a bit out of the box. And then, of course, the 100 million question, latency. If you do all those hops, how do you deal with latency? I wouldn't use this if I have to do latency, very specific latency sensitive applications. But what we are building websites, we have so much benefit, and there is like 10 nanoseconds which we every time add 10 milliseconds add when we hop between the Lambda functions, that actually the benefits outperform the cons. And be careful not building a monolith using microservices. From the moment you create dependencies between all those microservices, you're just building a monolith with a message bus in between. Try to avoid that too. So think really well about what is the responsibility from a single microservice. And if I ask you the question, what is that microservice doing? And you use the AND word, then your microservice is too big. Yeah? So just split it up in two separate microservices. So I would say kill that monolith, and thank you for listening to my talk, and make the microservice force be with you. I'm looking forward. I have a small teaser before we go into questions. We actually had a small, let me look. Here, Nikki, one of my team members, she wrote a serverless jukebox application, and she documented everything very well. So you can actually follow the whole tutorial with source code and everything available if you're interested in building microservices. Can we get the screen on for a sec?
Can you pass the screen back, please, guys? Sorry.
Not working? Okay, but I will put it, I will give the link so everybody can take a look. Yeah, thank you. So Nikki has written serverless GraphQL. It has full stack technology, architecture, and it goes further in the suggester and everything, how it works, uses all the S3 components. And then she also wrote a small app using React, which actually explains in detail how to use the technology stack. So feel free to look at it, to comment, to do some issues, to do some pull requests, to open some discussions, because at the end it's about community and to share experiences. That was it. Thank you very much.
Thank you. So we do have time for questions, if there are any questions.
First of all, thank you very much, Pascal. It was a great presentation. My question is, the size of microservices. You just mentioned the magical AND word, so if you use AND, maybe the size is too big. How can you find the correct size for a microservice, and how does the size vary to a general SOA service?
Yeah, size unfortunately does matter, because every service and Lambda function is actually spawned from 0. It means that you have a warm-up time. Yeah? And the bigger your application, the longer your warm-up time is going to be with Lambda. However, Amazon has done something, what is, the more traffic you get on that endpoint, they will actually pre-warm some instances of it. And in that way, you actually have less effect of the size of your service impacting the speed of the warm-up itself. But we keep services very small. We include only the libraries which are really necessary from a Node perspective. So be careful with those big libraries which include the half of the Node world. And just because it's only around 200 lines of code what we write. So keep things small, very testable, and very easy to execute. So in that way, yes, size has an effect on speed, but also on maintainability. And that's why we split things out in a very granular way. And it also allows you to do the CQRS architecture, where you have like a different way of how you write and how you read. We actually separate microservices from a read and write perspective too.
Okay, thank you very much.
Any other questions? No? Then again, thank you very much for sharing your experience.
Okay.